Can everybody hear me? Hello? Can anybody hear me? Am I audible? Hello, can everybody hear me? Okay. Everybody can hear me. Great. Hi, good evening. We are going to continue our JavaScript class from where we stopped the last time. So, but today we are going to be diving more into what we call object-oriented programming. So it's a very wide topic, and we're going to discuss a lot of things on it, the basic of object-oriented programming and the concept, and also we are going to implement some of it. We are going to practice, introduce us to classes, introduce us to constructors and the likes, inheritance, encapsulation, and abstraction. So we're going to practice everything, and really hope we get the most out of the class. And after the class, I will ensure us to read up more on object-oriented programming, because the concept is not only applicable to JavaScript alone. The concept is something you can implement into other programming language that we're going to be using in the future. Maybe where you will tend to move on from, like, the concept is just used across the programming language basically. So that's all. All right. So now, what do we now understand by um, object-oriented programming? So object-oriented programming in JavaScript is a paradigm centered around objects rather than functions. So what this basically means is that, okay, let me put my screen in the full screen. All right. I think this is very wide now. Everybody can see that clearly. All right. So now, what we mean by this is that the program is centered around objects rather than function, whereby JavaScript treats everything as objects. That means that if you have a specific variable, a specific object, it's going to have children. So we can, when you have an object, let's assume you have an object called person, you can have another object or thread or entity under it. So unlike procedural programming, which structures program as sequences of steps or logic. So in the sense that procedural programming, it is a program whereby you have everything listed to you step by step. So every execution comes step by step. But JavaScript object-oriented programming give us the functionalities of having everything, every object, every entity nested to each other like a chain. So when you have a single object, it's going to have a lot of nested objects assigned to it. All right. So, and OOP models complex system as interactive objects. So now, OOP allows us to model complex stuff into a simple thing, and what we can interact with. So we don't have to write a lot of spaghetti codes. You model real life objects, real life implementation. You translate it to code with simple steps. That's what OOP comes in. That's what it comes to solve for us. All right. So now we have said these guides will allow us to focus on core principles of object-oriented programming with some coding example. Like I said the other time, we are going to focus on core concepts, and I listed it the other time. So now, what is now the usefulness of this OOP? Why do we need it? But if we can write our code the way we write it and it works, why do we need to use object-oriented programming? Why? Now, the basic understanding is that modularity, it breaks down complex problems into smaller and reusable code. That's just basic. Now, there are a lot of concepts in the programming whereby when we are writing codes, you need to have at the back of your mind, we have something we call dry, DRY. Don't repeat yourself. When we're writing a code, a function, we're solving a problem, and we find ourselves repeating codes. We are repeating codes. The piece of code we write and implement in another file or in a class or in another component. We now need to rewrite that component again. No, we don't have to keep repeating ourselves. Why we can just create a function that hold and perform the same thing we want to do. So we don't need to repeat ourselves. All right. So now, maintainability. A well-structured code that is well written. You have your class well labeled, all the objects, all the functions, all the methods in it is defined properly. The class explain every implementation we want to do. Is you want to define a user entity, your class is designed for it. Your class allow you to specify all the methods a user should be able to register. A user should be able to create an account. A user should be able to check their wallet. All those methods are defined and solely tied to user entity. All right, so reusability, like we said the other time, instead of us writing duplicate code, why don't we separate it into a separate component and reuse it? So that's now we now find ourselves in one of the most important parts, which is encapsulation. That is that we keep data and method inside a single object, restricting access and protecting the state of the object. Let me emphasize on that. Encapsulation allows us to keep and restrict access to data. That is, when you have a class, you define all the objects and properties and variables to that class. We don't want outside parties to access that file or variables or that object. So when we get to the core part, we are going to introduce ourselves to why and how we use this encapsulation. All right. So let's move on to the next step. Please, if you guys can hear me very well, or if there is any issue, any question, let me know. All right. So now we have said fundamentals of open JavaScript. We have objects and class. I know we must familiar with objects, but we don't might not know what classes means. So now in JavaScript, an object is a standalone entity with properties and type. Standalone entity with properties and type. Now we are not enforcing the object right Hello, I'm not getting any feedback. Am I audible? Can anybody signify if you guys can hear me or can see my screen? Hello, hello, can anybody see me? Can anybody hear me and see my screen? Okay, can we move on? All right, all right, all right. Uh, I'm getting late feedback from you guys. All right. So now, if you guys understand what said the other time, that JavaScript-oriented programming will allow us to treat everything with objects instead of function. Now, this dog that we define, this dog object we define now, allow us to access everything inside this object with using dots to access everything. So we're going to practice it and show us how everything works perfectly soon. All right. So now, we now said the class is introducing ES6 JavaScript, and this will allow us to define the template that we need for what we want to define. For example, we want to define a well-structured template that will behave that will behave that will give us all the animal behaviors. So we are now going to define a class with a constructor to assign to the name of the class. All right. So now let me move on. Before we move on, let me explain what constructor is. Constructors allow us to specify the the variables or any objects that requires the class to perform very well, like basic authentication that require us to access the class. Okay, let's assume before before you can access your room, you need to open the door. So now, what is required? You need to unlock the door. So it's either you put in your key or put in your PIN or code to access the door. So the constructor is the key or the PIN for you to access your room, the door. So now that's what class and constructor means. We in OOP we model real life object or real life behavior. We translate it to object-oriented programming. That's why class comes in. We define everything we need into the class. All right. So now we need we define a class animal constructor. For the name, we want to assign a name to the animal. We need to identify the name of the animal. All right. So what are the behaviors the animal can perform? The animal can speak. Okay. So if the animal can speak, what do we need to the speak method to perform? We cannot implement the name to make a noise. So we are going to practice all these things now. So now we now have something we called instantiation. Like you want to instantiate a class. That means that you want to define the method and the object. This is what happened here. We instantiate the animal class and pass the constructor that requires us to access the class, which is the dog, and execute the function called speak on the animal class. All right. So before we move on, let me show us how the two implementation we discussed right now works perfectly. All right. Okay. So now let us implement what we talk right here. So we define an object. So we want to practice objects. Let me increase my screen so everybody can see what we want to work on. So we want to define an object called dog and assign couples of the breed, the color, and the back. What breed is the dog? The color of the dog. So we want to implement a behavior to it. Let us assume eat. So eat. So eat. We also want back. We want the dog to be able to bark. All right. So if the dog bark is this are the methods inside it. So what breed is the dog? Define it. Rottweiler. I don't know how to spell that. Rottweiler. Color black, and we want it to eat meat. How do we pass to it? Okay. All right. So I'm going to consider log. So let's assume we do this. Dog eat, and we allow it to console.log wolf. So now these are the methods we define and specify. So this is an object. So this dog holds all the entity and operation we want for the dog. So we can now access everything from the dog objects. So we can now, if we call dog dot, okay, let me console.log dog so we can see how beautiful it is to use JavaScript. We can see just by logging the dog objects, we can have an insight and understand on what we have under the dog object. Now we understand that, okay, this is an object and we can see everything clearly. We have 4 methods inside it. The back, the key value pair. The key is the back, but it's not just a key without a value, but a value of a function. Back, we have another key called breed with a string of Rottweiler. We have another key called color with a string of black, and another key called eat with a function. All right, so now using this, we can leverage another JavaScript function called length. Just by defining the object, we can know the total number of the total number of objects we have inside the object dog. So let me refresh my screen. It's undefined. Why? I'm coming. I'm coming. Why is it? All right, I'll fix that later. Okay, so now we can now access the objects we have inside it to define. Oh, the length is not an object that is not present in it. So now we can access the breed value just by navigating to the key, putting the key. Oh, someone said they cannot see my screen very well. All right, so we can also print everything we have under it just by executing it one after the other. So back, let's not forget the back is a function, and also it. So if we do this, we have undefined. What do we have undefined? Okay, this is a method that prints. So this is it. But if you also want to put this inside console.log, all I need to do is just return this as a string without logging directly inside it. So this is the beauty of object-oriented programming. Now, instead of us defining all these things as a separate function, back, it as a separate function, we can overload the dog objects with this attributes we need it to perform. All right. So, in fact, we can even leverage the concatenation. We can concatenate something like this: dog dot breed. What is it doing? The Rottweiler back. Woof. So the dog name, the dog breed, assign it to the back. So it's returning a string. So this back is a function that return a string. The same thing for the it. Okay, so this is basically how objects works. Now we now explain. We will translate all these properties, all this implementation we perform. We translate it to class base. So, but let me walk us through what the class is basically explaining the other time. So, we introduce a class. We're going to define a class animal to behave to translate all the behavior into class. So now, before we are implementing this, let me translate all these things we implemented right here into a class. All right. So let me implement that just right here. So I can comment this out to define a class that would behave the same way we want this to behave. We can define a class dog So we want the dog to have a name. We can define a constructor. So we can assign the behavior, everything we want to eat. We want the dog to have a name. We want the dog to have a name. We want the dog to be able to eat, to return eat, to accept a specific type of food. When we have a dog, we can decide to feed the dog fish today, feed it with chicken tomorrow, meat, any type of food. We want the class to be able to perform all these things. We want the class to tell us the color of the dog. Even we can set the color, we can preset everything. But right now, we are going to define the basic class without presetting it, without using the constructor. Now, let us go. Now we can define. Okay, let me show us how to do everything here. So we can define the class, this dot name. Okay, let me show us something very quick. Function name. Why do we have? All right, so let me show the constructor now. Okay, constructor name is going to accept the name. All right, so we define the name, and we can now define a method to get the name. So get name. So this will return this dot name that we define up. So if we instantiate the class, can we all see? So I will now implement the instantiate now. So that lets my dog equals to new dog, the class. So I will pass a name to it, Jack. So that's the name of the dog. I can now get the name of the dog by console.log. So I want to log it, my dog dot name. So because it's a function, this is what we have. This is what we have now. I think, can everybody see the screen very well? Can everybody see very well? So we define a class, a method that is name, and pass the name we want the dog. We want to name the dog Jack to it. So now if I refresh my screen, my dog dot name is not a function. Where is it? Oh, I made a mistake. Get name. All right. So if I refresh now, I can see Jack. So that's it. All right. So I can also specify the type of food I want the dog to be able to eat. All right. So we are going to create a function called eat. So what type of food I want to feed it. So I can now define we can define what we want the dog to eat. So Okay, let me try that from here. Name it the food. We assign the food, so we can instantiate that this dot food while doing this. So Jack eats meat. So I can now define this, return the name of the dog. You can return this, the name of the dog, this dot name, Jack, string, Jack eats space, the food, this dot food. What's the name of the food Jack eats? All right, so you can now print that. So console.log eat. So now I'm calling the eat method to allow me to understand what is eating. I will show us one thing right now. So if I refresh this now, so to show me that Jack eats meat, because I pass the meat. I want Jack to eat. I want to feed it to the dog. Come type. All right. So I know we can define it without actually specifying this on the point of instantiation. On the point I'm instantiating it. So now this eat needs to accept the type of food I want to pass to it. So I can now pass. Probably I want to change it. I don't want to feed it meat again. I want to feed it with chicken. So now I can define the dog name, get the name, and also specify the food I want to feed the dog. That's it. So this is how class and object work. Don't let us spend much of our time on it. We can be able to cover most of the class today. All right. So that's what class basically means. So let us proceed. What we mean, what we have something called encapsulation. So this might, all right. So now we have encapsulation means that the internal representation of an object is hidden from the outside. Well, I don't think we should talk about encapsulation before this. All right, let's talk about inheritance. We are going to come back to encapsulation. Let us treat all these basic parts before we talk about encapsulation. So it's going to be very easy for us to understand later. All right, so what we mean by inheritance with the basic English means that we inherit something or you inherit something. Basically, an object or a property inheriting something from another object or method. So that's just what it means with basic English. But now, how does that translate to what we need in the programming or in JavaScript? And what role does object-oriented comes in to play with that? So now, remember I believe we remember what I said something the other time about not repeating code. Fine. We can not repeat. We can decide not to repeat the code by just writing a procedural programming, just by writing function. Now we can define all those things without writing all this function in a separate way by putting all these things into a class. A class has a behavior all the functions and methods we define and properties we define inside this. Another class can also extend the class and inherit all the attributes that we have inside the class. For example, when we define the dog class the other time, that is, we have a dog class, we have a properties inside, a method inside it to eat. Basically, what the eat method is just performing is that is accepting the type of the food we want to feed to the animal. So now we cannot define another class that extend and inherit that object, that methods. So that would save us the stress of rewriting the same object that want to perform the same results for us. I don't know if you understand that. All right. So let me explain this one more time. So inheritance allow a class to inherit properties and methods from another class. What we have here, we define a class called animal and pass a constructor to it, a name, and define a function speak that allow us to log when the animal talk, like when the animal bark or when the animal make noise. All right. So now without define another class called dog that extend the behavior of the animal. So now we cannot also define another class that extend this behavior of animal. So let me show us how this work. So we define the class dog. Define the class dog over here. And what we look at is dog. It. We can also define another dog, another class. Class maybe goods. Because goods also eats. To extend dog class. So now, inside this dog, we can access all the methods, all the functionalities that we define in the dog. We can access it here. Let me show you the slide one more time so you can understand what I'm trying to explain. You understand? Inside dog, we define speak that allows us to show, to access everything inside the parent class. So I'm confidently use this again. Maybe I don't want you to give me something out of this. Let me define like a real world example. Let us assume we as human beings, we're person, we have a lot of things we're doing. That doesn't work. So when we work, we have a position that we find. And now we can define another class to show all the properties of the work we do. And we can also access everything from the class. So let me show us how that works. We can do everything design all the time. So class and we can expand this. So we get the goat to eat. So we can define our show what goat will eat. Show what the goat eats. I want us to see what I'm trying to explain here. So because what we're explaining here, this dog, we need to instantiate it again. We're instantiating it here. So we can now see something else. What the goat eats. I want to get the value from here. This dot eats. And I'm not defining it here. So this goat eats. What I'm going to goat eats is cereal or let's say corn. Okay, let me accept this. So goat food. Goat food. I will now class this eat. That is, we're extending this eat from dog. I can now class goat food over here and turn it. So when I try to get this goat food, it will return what the dog means. So if I do this, I don't know. Hope this is not. Do you have any question? Hello, can anybody hear me? People are complaining about the audio. Is the audio audible now? Is the audio audible now? I've increased my volume. Okay, is the audio audible now? Good, good, good. All right, all right. Okay, I'm very sorry. I've been focused on what to implement. I'm not, I'm checking the comments from another device. So sorry for that. All right, all right. Can I go back? Can I go back to start the explanation back, or you guys understand it to this place? Okay. Somebody said I should go back to where I started the inheritance. Favor Babatunde. Oh, I'm very focused on everyone. That's why we are here. Yeah. I'm very sorry. Okay. So where should I go back? Where should I start from? Okay. I think everybody stopped at inheritance. Thank you very much for calling my attention to that. All right. Without any further ado, let me go back. All right. So, what inheritance? Okay, because inheritance comes in to solve a major problem for us, which is to allow us to be able to inherit properties or methods, behavior from another class. So when we define the inheritance the other time, when we define the class dog the other time, the dog class consists of some behavior, such as the breed of the dog, the color, speak, and eat. Now, when we want to define another method, we want to define another class, we should be able to, instead of us to be able to rewrite that operation that we define, we should extend it. Since we have it in another class, we should extend that behavior to the behavior we are doing right now. We don't need to reinstantiate it, we don't need to rewrite it anymore, because it is present in the previous class. So now, that is why we have something like this over here. We have a class called animal. We pass the name of the class to it. This behavior, this name is defined, is solely tied to this animal. Then speak behavior is tied to this animal. Now, we now define a class dog to extend the behavior of this animal. So now, if this dog extends this animal, the only thing this dog can extend, can have access to, is the behavior, speak, and the name. So we don't need to define the name anymore inside this dog. We can leverage this part, this name. All right, I think this explain it. If this explain it better to us, let me try and implement this for us. I don't want us to get lost anymore. Let me cancel this. We have two class, animal, and we also have class dog. Two class. We want to define behavior in this animal, and other class should be able to extend the behavior. We can also have any other animal like goats, any other animal. So the behavior we have over here, animal we have name, isn't it? Animal should be able to speak. And animal can speak, it's not to be able to speak. Animal can speak. Then we all know that dog is an animal, it have a name. Dog can speak. Dog bark, but goats, what does goats? I think goats. Okay, let me use cats. I don't know what they call goats, but goats, cat mew. That's the behavior over here. So the name, let's assume we name this Jack, and the name of this cat, Pew. That's the name. The name over here. So this name will be generic. The name of animal here will be generic. So it's not static. And also the speak over here will be generic. But the behavior over here inside the class that we want to define will be back, because the behavior of dog is to bark, while the behavior of cats is to mew. Mew. Now, this animal class is the template. Let me use that word. Is the template, is the foundation. And dog and cats, we leverage and extend those things from animal. Let us implement it. It's not a magic. We will implement it right here. All right. So before we can access the animal class, like I said the other time, we need to define a constructor to it. Constructor, the name, and the speak. So this dot name equals to the name that we pass to it. This name we are passing it. This dot speak that we need. Speak. Then get name. Get the name. Return this dot name and the speak. It's also a method. Return. Let's use it this way. This dot name. What does it do? Speak. Cloche is back. This dot speak. So we've defined it inside this animal. Now dog can now leverage it. So inside this dog, all we need to do is just call this, because this class needs a constructor. We can just do super. What do we need? Okay, we need to extend animal. The name of our dog is Jack, comma, speak, back. Oh, I made a mistake. Constructor. Okay. All right. So I'm defining it like this. Dot speak, dot this, dot that, without actually passing this. So the same thing like this. So the name of the cat. Pure. And what is the behavior? Male. So, all right, this is it. If I now want to print it, let my dog equals new dog this, then console.log. See the beauty of inheritance. So my dog dot, can we all see? Get name, get speak, the name and the speak. All these things is not present in the dog class. Can we see what I just showed us? Dot get name. Get name is not present in the dog class. Can everybody see what I just show us? Get name is not present in dog class. So inheritance allows us to extend everything we have inside the animal class, just because we extend it like this. And before I forget, I use something here called super. Super allows us to do multiple layer inheritance, because animal require us to specify the templates, the parameter to the templates, before we can use it. So that's why I'm using super here. So if I run the code now, I'm going to see the results. Okay. Mm, unexpected, yeah. So I'm coming. Um, I thought they said we want to have a break. Let us go for the break and come back to fix this later. All right. Hello, we're back. Can everybody hear me now? Hello, am I audible? Can everybody hear me? All right, all right. Let us continue the class. Let us continue the class. Okay, so what I'm explaining the whole time, I'm trying to show us how we can access everything in the previous class. Class animal. Is this screen visible? Okay, class animal. We can access all the behavior inside class animal. And the behavior we have here is name and get name and get speak. So inside the dog, we should be able to access the name Jack like this. All right. So if we refresh this, super Jack back. All right. So we get the Jack name. Can we see? We get Jack name, and we did not define the method, or then we did not define the function to get this name inside dog. This get name, we did not define it in class dog. Do we see that? Can everybody see what I define now? We did not define the name inside the dog. And the same thing can happen here. The same thing can happen for the cats. Phew. The same thing for the cats. I can define let my cat equals to new cat and also dot log my cat dot get name. Can we all see? This get name, we extend it. Instead of rewriting the method inside the cat name and dog name, but define it inside the animal and allow every other class to extend that behavior. All we need to do is just pass the required stuff, the required attributes to it to let it perform the way we want it to perform. All right, let me refresh the screen and let us see. Why is this super messing up the behavior? My cat's get cat name is not a function. Oh, I did not extend. The extend is missing animal. All right, so now can we all see? Can we see? With just a get name function, a single get name function, we can implement the function, the behavior into two classes without actually writing it. Can we see? We define the animal class, get name inside this function, and all we need to do is just define this class, the two class, to extend animal. All right. Somebody asked a question the other time. Can this class work without actually using the super? Yes, it can work. Why we do this is because we want to leverage the constructor defined over here. Now, this can work without actually using constructor. Maybe if this class, we did not include constructor in this class, we did not define a constructor to it. That means that we are not going to do this anymore. We are not going to use the super anymore. You know, like I explained the other time, if you have a door, you want to access the door, you need to unlock it. That's why we need this constructor and the super. This is a constructor for the class that we extend. So I think that clarifies it. All right, let's continue to test the function, the last function before our time's run out. So we can also do that here. Get speak. So if I run it now, this is what we get. Can we see Jack speak? Because Jack speak, this is the action that does. Jack back, then Jack and pew mew. That's the behavior of cats. All right. Do we all understand? Or I need to rephrase everything I've been explaining? Hello? Can everybody hear me? Hello? I'm not getting feedback. All right. As much as I don't want us to spend the whole day on inheritance, it seems we're going to spend the whole day on inheritance. And let's not forget, we still have a long way to go on object-oriented programming. We have, let me show us what we have to go through. We still have polymorphism to discuss. We have abstraction to discuss. And we skip in encapsulation the other time. Okay. Okay. So let me rephrase one more time before we proceed. Okay, so inheritance. Hello, please, I want everybody to pay attention to this before I move on. Inheritance allows us to extend behavior from another class. That's the basic explanation to it. So the behavior you don't want to define, you want to extend it in another class so that you don't have to rewrite the code. Don't repeat yourself, like I said the other time. So that's why we have it over here. All right. So let us move on to the next agenda. We have polymorphism. So what do we mean by that? Polymorphism allows objects of different class to be treated as object of a common superclass. That sounds like something that is very deep, but it's not. I promise you it's not. So polymorphism is like the ability to define methods in a class to behave differently. So that is what we did the other time. Now we define a class in animal class to allow it to speak, right? We define the speak to it. Now, if you pay attention to what happened here, if we pay attention to what happened here. So we define a class called animal. We now define a function called speak into it. So we consider log animal speak. We now define a cat to let the method we define to behave differently. Previously we are passing like previously we are passing the parameters to it, but now we want to override it. I don't know if you understand what I explained now. Let us. I don't know. I need us to get. I need to get the feedback on this. Polymorphism. Polymorphism allow objects of different class to be treated as an object, like a single object of a common superclass. This is just a definition to it, but the simple and the basic English to that is that it allows us to let a class or a method we extend in the previous class to behave differently. Like we want to overwrite it, like we know that we borrow you, but the way we borrow you, we need it to work the way we want it to work. Like you will configure it instead of us using it the way we borrow it. We need to configure it to suit what we want to do. So that's just it. All right, let us do that and let us modify our class that we define to behave as a polymorphism. Okay, so now if you see what we have here, this speak, we define it like a default method to it, right? Now we want to overwrite it. Let's assume that this speak now, this is what we have here. We can now overwrite it. This is how it goes. Let me define that. Now, get speak. We can now overwrite it to this. Return dog speak. Overwrite dog speak. Dog speak. The same thing for cats. We are basically doing that. Okay, so you now refresh the code base now. Let me refresh the browser to show us the outputs. Can we see? Can everybody see the screen? Instead of us to allow that method to behave the way we extend it, the behavior that is configured for it to behave from where we extend it, but we choose to override it. So now the question that I'm expecting us to ask, or I'm expecting us to be bothered about, is that why do we need to extend it? Why do we need to borrow it if we know that we want to override it, instead of us just writing what we want ourselves? So this is it. Somebody asked how did they override that? We've already extended it. Don't let us forget. Don't let us forget that we already extend it. We define the class, the speak, and we extend it. Now, the moment we extend it, that allows us to give us the flexibility that we can override it, right? So now, this is where what we skipped the other time, encapsulation comes in. Encapsulation will not allow us to be able to do all these things. We can define a method or a properties, whether we want anybody that wants to access it to be able to override it. The behavior, you configure the type of the behavior, but I'm going to move on to encapsulation soon. But let me explain this polymorphism very well for us. All right. So, previously, what we have is that the get speak is coming from the parent class that we extend, that we inherit, and it's behaving the way we want it to behave. But now, the polymorphism will now allow us to overwrite everything. So, I want us to take our time to go and read on all these object-oriented programming, because it's very, very, very wide, and the moment we understand it very well, we can configure it to anything, any length, and the knowledge is very, very useful. You can use it in any other programming language you want to use. All right, so we are moving toward the ending of the class. Let me walk us through what we understand by encapsulation. So, all right. So encapsulation means that the internal representation of an object is hidden from the outside. So what do we mean? What do we mean? What does that mean? Okay, so we want to be able to hide some stuff, some behavior. If you are not, if you don't have access to this class, you shouldn't be able to do this. It's hidden. So let me show us let me walk us through the abstraction, so I can just brush through the two together. So this seems very similar, but it's not. So now the abstraction involves creating simple model representing complex and real-world objects, and it's also it's way powerful than the encapsulation. That is, it allows us to hide internal implementation details and showing only the essential features that we need. We can only show the parts that we want the outside world to see. When you extend a class, if you don't have access, if you don't have access to do this, you cannot do this. For example, when we define this vehicle class, we also define a car class. To extend the vehicle class. Then we now define it to be able to extend the start engine from it. Now we now pass the value we want into it. Now I'm going to implement this in a way that the variable, we are going to work with variable, with value right here. So do you understand what I explained before we move on to the implementation? I see that everybody is concerned about attendance. Do you understand what I'm explaining? Hello, can everybody hear me? I'm not getting feedback. Hello. Hello. All right. I think let you guys still want me to rephrase everything I've been saying. I think this is I think I've the class is too much for us. Okay, we can provide the slide. Somebody said I should go over it again. We have just less than 10 to 15 minutes to wrap this up. Okay, I think I just need to explain. See, we still have more to talk about. Asynchronous. These are my plans. We need to talk about the asynchronous JavaScript and explain what we should understand by asynchronous system, how JavaScript asynchronous work. But okay, so since everybody is just keen on this, I should brief everything for us one more time. All right. I'm still getting question on inheritance. Okay. Okay. All right. So let me move us through it one more time. Okay. All right. So let me start from objects, like I explained the other time. Okay, let me. So when I first start, I explain objects before I move on to class. I believe we still remember this. I explain class, I explain objects. Okay. Do we still remember how the object works and I explain it? Objects. Do we remember? Let me. Do we remember how the objects work? Okay, so I explain objects in a way that I explain that objects is a is an it can be an instance of a class. Sometimes maybe when we instantiate an object, we can get when we instantiate a class, we can get all the attributes from the class by just doing dot 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 to get the properties and what we want to access in the class. So now this my cat is now an object because every method defined inside the class is nested. Okay, so now we understand that when we now define the object, we specify the method, the behavior we need in it. So it's a basic explanation of how to implement a real world stuff using the objects. Now, when I move on to class, let's pay attention to this place. When I move on to class, so a class consists of all the properties of the real world objects that we want to perform. We want the class to behave. I'm citing an example of a dog right here. You can define a class to mimic the operation of a real world school system. You can define a class for students. You can define a class to handle the student's name, the course the student offers, the grade of the students. You can define a lot of methods to it inside that class to define to get the student's fees record. So all these things you can define it as a method, as a variable attributes, the way you want in the class. And also, we now move on to explain what we understand by inheritance. So now, in inheritance, I explained that inheritance is very simple. All you need to understand is that you have to inherit to you have to inherit an behavior of a class into another class, like you are injecting the behavior into another. So now there is a specific method in object-oriented programming that people question a lot. Can we extend multiple class? What we have here, we're extending a single class. We're extending a single class. So I want us to go and do that research. How do we do multiple inheritance? Understand reason for multiple inheritance. So all these things are the things we need to sit down, read, learn on our own. Based on everything we've been doing in class, we can just sit down, read up on all these things. A single inheritance is what we've been implementing since. There's something called multiple inheritance. We can go and read up on it. All right. So now, we now move on to discuss what we mean by constructor. Constructor is very simple. Constructor is very simple. It's it's the gateway to access a class that is logged. The class cannot execute if it did not pass the required parameter to it. It will not work. Do you understand? All right. So now, I explain what we mean by polymorphism. So, what polymorphism means is that we have different um, methods and class that we inherit in the class, but we want it to behave in a different way. So a single class can behave in multiple ways. So we have the get speak that we define inside animal, but when we extend it to dog, it behaves in a different way, but it's still the same. It's still the same method. Poly means to enable you to behave in multiple ways. Poly. So now, and we implemented it, and also we now talk about abstraction. So abstraction simply means by hiding details of a class. That is that you don't want other class to override what you want. So you hide it, or you don't want the get name. You don't want access to the get name from outside of the class. Do you understand? All right. Do you have any more question? All right. Do you have any more question? Any more question? question? Hello, can everybody hear me? So we are going to give us more links. We are going to provide links, resources for us to learn on all these ahead of the next class. Because we need to understand all these basic concepts of OOP, because it will help us a lot when we start working on all the front end and back end that we want to work on. All right. So the resource will be sent to us via all the channels we are using, either the LMS or the Telegram. So we're going to provide that. All right. That will be the end of our class for today. And any question that we wanted to ask should be sent to us directly. All right. Thank you very much. And I'll see you guys in the next class. And do have a great day.